1, 2, 3, let's go!
Hey guys, it's me, Ashley the Math Tutor. Welcome to my first video. I have seen so many new comments and subscribers, and I just want to say thank you guys so much to everyone that's been showing love and everything. Like, you guys are so sweet. I love you guys. I appreciate all the love, and you guys are so sweet. Like, I love you guys. Thank you so much. And I am so excited to be uploading my first tutoring video. Yay! But before we get started with today's video, there are a couple things that I do want to address. First off, I am so sorry that it took me so long to upload my first YouTube video. And I'm going to try to upload every 2 weeks starting from now. Before, I think the last time I uploaded was like late March, and it's like June, it's late June, and honestly, I'm just so sorry that it took me so long, but I was like so busy, you guys have no idea. But luckily, I finally have settled down, and I can get into posting more consistently. And like I said, I will try my hardest to upload every 2 weeks. Secondly, in my previous videos, I had a lot of people ask me questions about the shell, disc, and washer method that I feel like I couldn't really answer like in the comments. I would have to like show like a video to answer their questions. And I'm definitely going to answer that in a later video that I post. And that's probably going to be my next video. Not in the next 2 weeks, but probably like in a couple of days or so. I got to like get to everyone's questions and all. So yeah, I'm definitely going to answer those guys' questions. And thirdly, okay, so apparently there's this other girl on YouTube, and she was featured on the My Story animated YouTube channel, and her name is Ashley, and she's also animated in her video, and she's also really smart in math.
Hi, I'm Ashley, and my family's hate for me wasn't new. Another time when I was bored in recess, I saw the math teacher and a senior working on something. I passed by them and saw they were working on a question. They seemed stuck, so I offered to help and solve the question in a minute. They were stunned.
Basically, it's about this girl who's like totally a math whiz, and she gets like into a lot of like family drama. And someone in the previous video asked me, oh, is Ashley the math tutor the girl from the My Story animated? And just to confirm, no, that is not me. But yeah, just to clarify, even though we're both good in math and we both help people in math, we are not the same people, just for clarification. Okay, so like I said in the previous video, since I started off with Calculus 2 content, I'm going to continue with Calculus 2 content and then work my way down from Calculus 2 videos to Calculus 1 to Trigonometry to Algebra 1. I was thinking about it, and I might cover pre-algebra as well later as well. Also, I am going to be going off of the book Calculus Early Transcendentals, is that how you pronounce that? Oh my god, sorry. I think it's transcendentals, whatever the word is. I'm going to be going off of the textbook Calculus Early Transcendentals, 3rd edition by John Rogowski and Colin Adams. Oh my god, I'm so sorry not to get distracted, but this caught me off guard. Isn't the name Rogowski? Wasn't that the guy from Monsters, Inc.? Wasn't that his name? Mike Rogowski, the guy, like the one-eyed green guy. What was his name again? Was that his name? Okay, so update. I literally became so curious as I was like editing the video that I just have to look up his name. What was Monsters, Inc. characters names? What was their name? Oh my god, this is gonna kill me. Mike Wazowski. That was his name. Okay, it was not Rogowski. Okay, oh my god, I'm so sorry. I keep getting distracted. Okay, let's really get back to the video. I'm sorry, that was gonna like kill me. Okay, now that my curiosity has been, addressed, back to this, what I was doing. So anyway, I'm going to be going off of this book, and I have the PDF file, and I'm going to upload it to Google Drive, and I'm going to put the link to the PDF file to this textbook in the description box in every video, so that way you guys can have like a free reference book, because this is the textbook I'm going to be going off of. I will also be tutoring based off of the notes that I create that I'm going to like show you guys in the videos, and I'm going to upload these notes that I go off of when I'm tutoring in a Google Drive document, and I will share that with all of you guys as well in the description box. The link to all the notes will be in the description box as well. In the next couple of videos, I'm going to be discussing integration techniques. This includes integration by parts, trigonometric integrals, trigonometric substitution, hyperbolic integrals, integration using partial fractions, strategies for integration, improper integrals, and numeric integration. If you follow along in the textbook, this is in chapter 7 of the book. There's this one section that I won't really cover in chapter 7, which is the probability of integration section, because honestly, I don't know too much about that topic, and my professor didn't really go over that section that much, and honestly, I can't tutor something I don't know about, but I will cover all of these topics that you see in the picture. In this particular video, however, we're going to be discussing the integration by parts technique, which is on page 373 of the textbook, and that's also section 7.1. Okay, so like I said, in the next couple of videos, we're going to be discussing different integration techniques. And in this particular video, part 1 of the different integration techniques, we're going to be discussing integration by parts, which, like I said, is on page 373 of the textbook, or section 7.1. In this tutorial, we're going to cover what integration by parts is, when to use integration by parts, how to do integration by parts. Let me put it down. I don't think you guys saw that one. How to do integration by parts, various examples of integration by parts, and little helpful tips and tricks for tricky integration by parts problems. This one is really going to come in handy. Okay, so for a little introduction of integration by parts, what we use the integration by parts method is we use it when the integrand, and the integrand is the equation that is about to be integrated, is a product of two functions. So basically, use it when the integrand is two functions that are multiplied together. And by the way, a lot of people, when I was tutoring other calculus students, a lot of people did not know what an integrand is. All an integrand is just like the function that's being integrated. So whatever's in between the little squiggly integral line, the little squiggly integral symbol, and the dx, basically what's in between that, that's an integrand. So this in the box is the integrand of this integral. This right here in the box in between the squiggly line and the dx, that's an integrand. And this integrand is two functions that are multiplied together. The first function is x and the second function is cosine x. So now that we know what an integrand is and when to use integration by parts, let me give you guys the equation for integration by parts. You might want to write this down now because this is very important. The integral of u dv is equal to uv minus the integral of v du. And basically, as you can see, u and dv are two functions. Can you guys see that? U and dv are two functions that are multiplied together. So these two is going to be an integral that has an integrand of two functions that are going to be multiplied together. So the integral of these two functions that are multiplied together is equal to uv minus the integral of v du. That's the equation for integration by parts. Okay, so as I've been making this video, I realized something that could be considered a little confusing to the people watching this video. I've been saying the phrase "you" a lot, and it refers to like you in two different contexts. One way I've been using the phrase "you" is as in the variable u in the integration by parts equation. And the other way I've been using the phrase "you" is like as in you, the person watching this, like you, the viewer. I try to be very clear and concise, and I'll try to add captions to the video so that way the captions will show the differentiation between when I'm saying you as it pertains to the equation versus you as in the person watching this, like you watching this. I'm sure you'll be able to pick up which is which just due to like context clues, but I just want to make sure that I'm not being confusing. And also, I'm also going to add captions just in case anyone watching this might have any like hearing disabilities, or like if English is not their first language or something, and they can that way look at the script of the text of the captions if they need to like translate what I'm saying. I tried my best to be like mindful of anyone that could be potentially watching this video. So yeah, be sure to write down this equation right here. The integral of u dv equals ub minus the integral of b du. This is a very important equation. All right, so let's get into it. All right, so for step 1 of integration by parts, we're going to determine which function in the integrand will count as u and which function in the integrand will count as dv. Here's a really helpful tip. My former professor said it was much easier if you go by this rule. Pick the function for u as a function where it is easy to find its derivative, and pick the function for dv as the function where it's easy to find its integral. You don't have to do this, but I really, really recommend that you do this. It would come out the same way if you didn't do it this way, but it's so much easier and so much more clean and concise when you do it this way, and it stops like the potential for the integral to like repeat and reiterate such that you would have to do it over and over and over again. So this is just a really, really helpful tip. Pick the function for u as the function where it is easy to find its derivative, and pick the function for dv as the function where it is easy to find its integral. Be sure to write this 2 down. But all we're going to do in step 1 is determine what's u and what's dv in the integrand. Now, what do I mean by easy to integrate versus easy to take the derivative of? Let me use an example. Take this example, x cosine x, which is the integrand that I used in the beginning, right? So let's take this function of this integrand. It's 2 functions. It's x cosine x, and it's multiplied by it together. So let's take this equation and let's make an example of it to show an example of what I mean for easy to integrate and easy to differentiate. Let's use an example. So there are 2 equations here. 2 equations in this. There are 2 functions in this equation. One is just x alone, and then the other one is cosine x. So let's take the integral and the derivative of both equations. So the integral of x dx is going to be x squared over 2, and then the derivative of x with respect to x is just going to be 1. Now, when it comes to cosine x, the integral of cosine x dx is going to be positive sine x plus c. And then the derivative of cosine x with respect to x is just negative sine x. Oh, I forgot the plus c here. Oh my god. Let me just write plus c really quick. Sorry, guys. Plus c. Sorry. Anyway, I forgot the plus c. But anyway, let's keep going. So for the integral of x, which is x squared over 2 plus c, the x in the answer, that x is to the second power. For the derivative of x, which is just 1, which is a constant, x is to the power of 0, because anything to the power of 0 is 1. So it was just, because it's a constant, there's no x there. So it would just be x to the power of 0 times or plus whatever constant is there, or whatever, what have you. So since x is to the power of 0 and there's no x here, x is to the power of 0 in the derivative of x. Now if we go on the other side with cosine x, the integral of cosine x, x is to the first power in the positive sine x plus c. And then for the derivative of cosine x, which is negative sine x, x is to the first power there as well. As you can see, in the integral of x, when it comes to the function x, the integral is of x is to the second power, but the derivative is to the power of 0. So that means the derivative has a lower power, or is to a lower degree, than the integral. which means that it's easier to take the derivative of x. The goal basically is to choose whichever one is easier is the answer. Whichever one would be easier would be the one where the answer to whether it be either the integral or the derivative has the lowest degree. Since the derivative of x has a lower degree than the integral of x, x is easier to take the derivative of than it is to take the integral of. With cosine, they're both to the first power when it comes to the derivative of cosine x and the integral of cosine x, so they're both to the first power, so that one doesn't really apply. But when it comes to x, this rule does apply because the integral is harder to take than it is the derivative, because the derivative is easier because the power that x is to, which is 0, is lower than the power of x in the integral, which is 2. So in this particular case, x would be easier to differentiate. So since x would be easier to differentiate, we will use x as u if we were to have the x cosine x as our integrand. And then since the cosine x, they're both to the first power, so this one doesn't really apply. But since we already have x as u, we have but no choice to have cosine x as dv. The derivative of x is 1, making it easier to differentiate. This is because we're looking for the answer with the lowest degree. X squared over 2 is to the degree of 2, but 1 is to the x in 1 would be to the degree of 0, because x to the power of, you can think of 1 as x, let me write this down so you can think of 1 as, let me focus it. Yep. You can think of 1 as x to the 0 power plus 1, since 1 is just a constant. X to the 0 power is just going to be 1, maybe times 1. Sorry. X to the 0 power times 1. So x to the power of 0 is just 1 times 1. So this right here has a power of 0. Yeah, it's supposed to be x is 0 times 1, not plus 1. So I fixed that. The dot looks kind of big, but you guys get my drift. This is the power of x 0, and this is to the power of x squared. So this is 2 is greater than 0, and 0 is less than 2. So this is easier to take the derivative of, because this is the lower power. This one has the equal amount of difficulty to take its integral and its derivative, because the x here in sine x and the x here in the negative sine x, they're both to the power of 1. It's not x squared, x cubed, blah, blah, it's just x. So they're both, and same for here. So they're both to the power of 1. So this has the same level of difficulty, but this has the degree here in x is lower than this. So it's easy to take x's derivative in this integrand, in this function right here, these two functions, in this equation right here with these two functions multiplied by each other. If this was the integrand, we should make this u. We should make x u, because it's easy to take the derivative of. And since these have an equal amount of difficulty when it comes to taking its integral or its derivative, this is kind of an equal amount of difficulty. But since we already have this as u, we have no choice. Since we already have x as u, we have no choice but to make cosine x our dv. Alright, so for step 2 of integration by parts, what we're going to do is we find the derivative of the u function and then find the integral of the dv function. This is the integral of u dv. We're going to find the derivative of the function that is u, and we're going to find the integral of the function that is dv. We chose u, and then we chose dv in the previous step. So now all we're going to do is take whatever's in this box and then find the derivative of whatever's in this box, and we're going to take what's in this box and find the integral of whatever's in this box. The derivative of u is du over dx. Well, the derivative of u with respect to x, I should say. Let me write that in the bottom. Let me put with respect to x. Yeah, with respect to x is du over dx. And then the integral of dv is v. Now, I know I left out the plus c with the integral, but after the v, we don't really need the plus c right now. We're going to do that all the way at the end. We don't need the plus c. I know with integrals you have to add plus c, well, for improper integrals, or for the, what is it called? Indefinite integrals, or whatever it's called. The integrals that don't have a boundary, you know what I mean? The ones that don't have numbers on the squiggly line. So I know you have to add plus c for that, but these, right now, we don't need to worry about the plus c. We're going to do that all the way at the end. Now, all right, for step 3, we take the function you found for du over dx, which is u's derivative, and cross multiply in order to find du, because we have to get du alone. Once we're doing integration by parts, we need, let me focus it again. We need this du, so we have to get du alone, so we have to cross multiply. Du over dx is going to be equal to the equation you found the equation you found for u's derivative, whatever that equation is, divided by 1. So du over dx is whatever you found for u's derivative divided by 1. And then if you cross multiply these two, this crosses and this crosses, it's going to be du times 1 is going to be equal to the, so du times 1 right here is going to be equal to the equation you found for u's derivative times dx. So yeah, we cross this and then we cross this. So du times 1 is going to be equal to the equation you found for u's derivative times dx. And then since du times 1 is just du, it's going to be du is going to be equal to the equation you found for u's derivative times dx. We got to get this du alone. This is really important. Now for step 4, now that we have u, v, and du, let's set up the equation for integration by parts in order for it to be solved. So like I said, this is what you wrote down. This is the right side of the equation that you wrote down in the beginning, which is u times v minus the integral of v du. We're going to use this as our format to set up the equation. To answer the integration by parts. U is going to be what you chose for u, multiplied by, that's this little dot right here, multiplied by v, which is what you found for v. Once you integrated dv, you found v. So this is going to be what you found for v, minus the integral of what you found for v. You write that again here, multiplied by what you found for du. And this is u's derivative cross multiplied. When you got to get du alone, like we said in step 3. So this is the setup of the integration by parts to solve the problem, and then this right here just breaks down what each box is. U is going to be what you chose for u, multiplied by v, which is going to be what you found for v, and then we're going to minus all of this. All of this is going to be minus, not minus this. This is minus that. Sorry. So this, all of this, minus the integral of what we found for v, we're going to write that again here, multiplied by what we found for du, which is what we found when we cross multiplied the derivative for u and we got du alone. So this is basically the format for the answer for integration by parts. Now for step 5, we solve the equation that we just set up in step 4. At the end, you can add plus c to the answer for the integration now. Now at this end, we add plus c. So like we did before, the ub minus the integral of v du, how we set up this equation in step 4, whatever this equation was, literally just solve it. So after you find this, the integral of v du, now you can add the plus c. Now, usually in this step, our main focus is to just find the integral of v du, because uv can be written as just uv, usually. If uv can be simplified or grouped together, then you can do that. But usually it can just be written as uv. Yeah, this is pretty much just done, and we just got to find the integral of this, and then you slap plus c on that bad boy, and you're pretty much done. All right. For step 6, this is just like, a check your work kind of step. Your answer should look like this. U times V minus the integral of V du, which is U is what you chose for U times V, what you found for V, minus the integral of V du, which is what you found for the integral of V du. So whatever you found to be the answer to this integral, you do it here, and then plus C. That's pretty much what what the format of your answer is going to look like. If you can simplify it more from this step, then you can do that by all means. But if not, just leave it like this. Okay, so let's use some different examples to show how integration by parts work. And I'll be using the steps that I showed you guys to solve this problem. So let's start with example 1, which is going to be the integral of x cosine x dx. The reason why we would use integration by parts here is because the integrand, which is, like I said, what's in between the squiggly line and the dx, and is basically the equation that's going to be integrated. This right here is two functions that are multiplied together. This equation is two functions multiplied together. The first equation is x, and the second one is cosine x. I used this integrand when I was explaining the example of what's considered easier or like more difficult to find the integral or derivative of. So we already established that for something like this, x is easier to take the derivative of, because the degree of the derivative of x, in x's derivative is lower than the degree of x in x's integral. So we're going to make x u here, and since we would have no choice other than cosine x to make it dB, we'll make it dB because we have only one other thing here. So for step 1, we're going to choose u and choose dB. Like I said, x would be u here, and then cosine x would be dV. So that's our step 1. We have our u and we have our dB. Let's go down to step 2. All right, so let's move on to step 2. We're going to find the derivative of u, which is du over dx, and then we're going to find the integral of dv. So we're going to find the derivative of u and then the integral of dv. So since we chose x as u for our last step, the integral of, not the integral, oh my god, I'm sorry. Since we decided x to be u, the derivative of u is just going to be 1, because the u is x, and the derivative of this x would just be 1. It's just, x, the derivative of x would just be 1. So since we found cosine x to be our dv, we have to integrate both sides because we have to find the integral of dv. So what we do to this side, we have to do to this side. So the integral of cosine x, we're going to take the integral of dv, which is going to be the integral of cosine x. And by the way, the integral of dv is equivalent to the integral of 1 dv. And this one would just be v. So every time you see the integral of dv, it's just v. That's it. The integral of dv is just v, because you're just taking the integral of 1, which is just v. And remember, don't put plus c just yet. Don't do that. So the integral of cosine x is going to be the integral of dv. So that means v is going to be sine x, because the integral of cosine x is sine x. So for our step 3, we're going to cross multiply in order to find du, because remember, like I said, we got to get du alone. This is going to be very important. So we saw that earlier in step 2, we saw that du over dx is 1, right? So if we take du over dx and we make it equal to 1 over 1, because anything divided by 1 is just itself. So du over dx, we're going to equal that to 1 over 1. And if we cross multiply, du times 1 is equal to dx times 1, which means du is equal to dx in this step. In step 4, we're going to set up our equation. Like I said, it's uv minus the integral of v du. So we chose u to be x. We found v, which was the integral of cosine x, which is sine x. and then minus the integral of v, we're going to write v again, we found that to be sine x, times du, which was 1 dx, or just dx, because remember in the previous one, let me get that, in the previous one, du times 1 was just dx times 1, and so du is dx times 1 or just dx. I just put times 1 just because, but yeah, so du was 1 times dx or just dx. And in step 5, we're going to solve this equation. So the equation that we set up in step 4, we're just going to quickly solve it. So it's going to be x sine x minus the integral of sine x times 1 dx, and sine x times 1 is just sine x is times 1. So this is really the integral of sine x dx, and the integral of sine x dx is negative cosine x plus c, but since this would have been negative and there's a negative here, I just made it positive. So the answer is x sine x plus cosine x plus c. Now you can add this plus c because it's the end. But just to reiterate, the reason why this is positive is because the integral of sine x is negative cosine x. So that negative would have made a positive here. So now that we've solved the equation, this is the answer, and we can add plus c in step 5, like I said. So the answer would have been x sine x plus cosine x plus c. In step 6, you just check to make sure the format of your answer is correct, or basically check your work. Like I said, you can go back and check to make sure the format is correct and make sure you didn't make any mistakes, check your work. And also, you can use Symbolab or Mathway, which are websites that basically allow you to input integrals, derivatives, and other equations. And they'll give you the answer. So you can also use Symbolab.com or Mathway.com to check your work. I'll be sure to link those websites in the description as well. So, you can just always check your work to see if you got the answer right. Excuse me. So in conclusion, like I said, the integral of x cosine x dx is equal to x sine x plus cosine x plus c. Alright, so let's do a second example. This is going to be example 2. So we have the integral of 2x plus 9 times e to the power of x dx. The reason why we would use integration by parts here is because, well, let me put e to the power of x in parentheses as well so I can illustrate my point more properly. 2x plus 9 is a function, and this function is multiplied by e to the power of x. The integrand is two functions multiplied by each other, so we would use integration by parts here. So let's get started. So step 1, we have to choose our u and choose our dv. So I set up this little chart here. Here's the function. Here's each function in here. One is 2x plus 9. That's this function right here. And the other function is e to the power of x. The two functions are basically what two functions are being multiplied. So here's the first function, 2x plus 9. And here's the second function, e to the power of x. And so the integral of 2x plus 9 dx, if you look closely, I don't know if I can I zoom in on this? Yes, I can. Okay, so the integral of 2x plus 9 here, the integral of 2x plus 9 dx is 2x squared over 2 plus 9x plus c. And then the derivative of 2x plus 9 is just 2. Now, if we go on over to e to the power of x, the integral of e to the power of x is, well, e to the power of x. And the derivative of e to the power of x is also just e to the power of x. So as you can see with this one to the 2x plus 9, the degree in the answer to the integral is to the power of 2. That's the highest degree. This x right here is to the power of 1, but that doesn't matter. In this whole answer for the integral, in this whole entire answer, this is to the power of 1, but the highest one is what we care about for the x's, even though there's two x's here in the answer. This is the higher one, which is x to the second power. So this whole function is to the out of this x and this x, this has the higher function. So we can say that this whole thing right here, the highest degree is 2. And for the derivative, there's no x here, so the highest degree is 0. So since the derivative, the answer's degree of x is 0, but in the integral, the highest degree of x here is 2, 0 is less than 2. So since this has the smaller, what is it called? The smaller degree of x, the derivative has a smaller degree of x like it was last time, we're going to say that 2x plus 9 is easier to take the derivative of. Because this is just 2, which has the power, where at here, the power of x is 0, but here, the power of x is 2. 0 is less than 2, so for 2x plus 9, it's easier to take its derivative. So let's choose 2x plus 9 as 2. Here, it's kind of the same as before, both e to the power of x and e to the power of x. Both of the x's here is just to the power of 1. It's not like it's e to the x squared or e to the x cubed or e to the x squared or e to the x cubed. Here, it's just e to the x. They're both to the power of 1, so this is both equally, has the same level of easiness to integrate and to differentiate or to take the derivative of. So this is kind of like equal amounts of levels of difficulty. So for this, for 2x plus 9, we're going to make this our u. And since we already have chosen our u, we have but no choice but to make ex our dv. So the degree of x in 2x squared over 2 plus 9x is 2. That's the highest degree in these two things. Like I said, I know there's two x's, but we're worried about the x that has the higher degree. That's the most important one between these two. And the degree here, the highest one, is 2. The degree of x in 2 is 0. And 0 is less than 2, so 2x plus 9 is easier to take the derivative of. So like I said, we're going to use 2x plus 9 as u. That means we would have to, I meant to put u's here. Sorry. We would have to use, oh, you can barely see that. Where's my other pen? We would have to use, oh, are you kidding me? Oh, you can kind of see it. We would have to use ex as dv. So yeah, we would have to use ex as dv. So in conclusion, for step 1, we've chosen our u to be 2x plus 9, and we've chosen our dv to be ex, e to the power of x. All right, so for step 2, we're going to find the derivative of u, which is du over dx, and we're going to find the integral of dv. So our u is 2x plus 9. So to take the derivative of this u, which is du over dx, which is taking the derivative of 2x plus 9, that would just be 2. Because remember, the derivative of a constant is 0. So that would just be 2. So yeah, du over dx here is just 2. And so since we said our dv was ex, we're going to take the integral of dv, and that would be the integral of e to the x, and that's just e to the x. And remember, the integral of dv is b. We discussed that in the previous example. So v is equal to e to the power of x. And remember, do not put plus c yet. Do not put plus c yet. Only do that at the end. All right, so for our step 3, we're going to cross multiply to find du. So since we found du over dx to be 2, we can put this 2 over 1 since anything divided by 1 is itself. So we're going to cross multiply, and we have du times 1 is equal to 2 times dx. So du times 1 is equal to 2 times dx. And then anything times 1 is itself, so we can just make that du. Oh, sorry. And then du is equal to 2 dx. So yeah, that's step 3. In step 4, we pretty much just set up the equation like we did in the last step. So the format is uv minus the integral of v du. So we chose u as 2x plus 9. We found v to be e to the x minus the integral of v, which we found to be ex, times du, and when we got du alone, we got it to be 2 dx. So du is equal to 2 dx. So uv minus the integral of v du would be equal to 2x plus 9 times ex minus the integral of e to the x times 2 dx. So now that we have our equation set up, we can go on down to step 5, and we can solve the equation that we set up. So 2x plus 9 times ex, like I said, this is pretty much done. We don't have to really simplify this any further. This is pretty much done. So this side is done. We just need to focus on solving the integral of v du. So 2x plus 9 times ex, that part is done, minus the integral of e to the x times 2 dx. So this is a constant, so we can move this on to the outside of the integral. So it would be what we had before, 2x plus 9 times ex minus the constant, which is right here, 2, times the integral of e to the x dx. Now the integral of e to the x is just e to the x. So we have as the final answer 2x plus 9 times e to the x minus 2 times e to the x plus c. Remember to add c at the very end. We can add c now since we're done. And for step 6, we can just check to make sure the format to the answer is correct, and be sure to check your work. Like I said before, you can use Symbolab or Mathway. So we have as a final answer the integral of 2x plus 9 times e to the x dx is equal to 2x plus 9 times e to the x minus 2e to the x plus c. All right, so this is the answer to this integral.